name's Alex. I'm talking today about time, or state time and concurrency. And this is a high school senior photo so as to establish some degree of humility. I'm the former core team member, now Ember core team emeritus. I work at a company called Future Proof Retail. We have built and maintained a suite of Ember apps that kind of target retailers, grocery stores. The most popular of the apps being a mobile line-free checkout app where you can scan items on your phone and check out and skip the line. And so I've got plenty of experience in the last few years doing mobile apps and dealing with concurrency. So state, time, and concurrency. Maybe let's define a few terms. So state is the data in your app that changes over time. Async operations, which might be emitted or kicked off in your app, take time and usually cause state to change. And concurrency is any time that you have more than one async operation happening at the same time. And I would sort of argue that the user is kind of an async operation. The user will get impatient and will triple click the form submit button. And we'll click the refresh button if things don't load fast enough. So any app that has any async on its own, any timer, any AJAX request is already concurrent because there's always the user. And concurrent programming is pretty hard. Still, it's pretty hard. And unfortunately, it's pretty much all that web development programming is. So Ember Concurrency is an add-on that I wrote maybe a little bit more than a year ago that helps you manage and deal with state, time, and concurrency. And it's one of the more popular Ember add-ons. Maybe a quick show of hands, who uses Ember Concurrency in a production app? It's pretty good. It's like 50% so. So to sort of highlight what's actually difficult, I'm actually going to stick with a pretty simple use case that gets hairy pretty quickly. So this is actually a use case that's lifted from my own app for the mobile checkout, where one of the first things that you have to do is geolocate, get your latitude and longitude coordinates, and then forward that information to the server so that the server can tell you nearby locations that are supported that you can check out at using this app. And so we're going to start off doing this in a very vanilla, typical Ember fashion. We're just going to have an action called submit form. It's going to make use of a geolocation service. It's going to make use of a store, a data store, and it's going to say geolocation.getCoords. This returns a promise. When the promise fulfills, we're going to take the coordinates that were returned from the successful, hopefully, geolocation request, and we're going to forward that to get nearby stores. And that's going to return a promise that fulfills when we have a list of stores that are nearby. Then we're going to take that result and we're going to set it as a property on this component so that it's exposed to the template and the template can render it. So if I click this button, it's going to take 2 seconds and then the results are going to show up. There's a Flux Potle, there's a Flux Central, there's a Fluxes are us, there's Transclusions are us, which is a competitor. And throughout these examples, I'm going to be moving around in the world so the results will change. So this is not really ready for production. You wouldn't ship this because clicking this button gives you absolutely no feedback as to the fact that something's happening behind the scenes. So let's fix that. The first thing we'll do is we'll add a isSubmitting flag, and we're going to set it to true at the beginning of the action. We're going to set it to false right after we get the results back. So we can use that isSubmitting to drive the state of the button. So now it says finding, and there's at least some feedback that something is happening in the app. But we're still not done because if I button mash, which you can't tell that I'm doing, but if I tap this a bunch of times in a row, I'm actually kicking off a bunch of async operations and getting coordinates multiple times and asking the server multiple times to find nearby locations. So we're still not ready to actually ship this to production. So really this is an issue of unwanted concurrency. We've made it really easy to kick off an async operation, but we've also made it really easy to kick off an async operation while one's already running, and that's the definition of concurrency, and we want to constrain that. So we just add a single line of code, we reuse this isSubmitting flag, and we check it at the beginning of the action, and if it's true, that means we've already kicked off an action before, and it's not done yet, so it'll just return early. So if I button mash, this at least solves the problem of kicking off multiple operations. It just makes sure that only one fires off. Are we done? Are we good? Unfortunately, no, because we log into our error reporter, we log into Bugsnag or whatever, and we're seeing that there's a bunch of client-side errors along the lines of calling set on destroyed object. We get so frustrated with Ember that we throw out all of our code and we rewrite and React and apply the same methodologies, only to realize that we run into the same error with slightly different copy. which says, this usually means you called setState on an unmounted component. So this is just to highlight that this is not an Ember specific thing. This is something that frameworks in general that don't really give you great async primitives or concurrency primitives, it's something that you have to deal with kind of everywhere. But let's press on. We're going to stick with our quickly degrading Ember-based example. And so we had a little bit of defensive programming. We check if this is destroyed. So because components extend Ember object exposes whether an object is destroyed, you can just check this.is destroyed and return early so that these potentially dangerous sets don't happen, right? And I don't really have any code to validate this is actually working. It's honestly, when you start adding these to your code base, you're probably not testing each one. Maybe you are, but it's everywhere, and that's just such a harrowing task. So that works, but then you get a feature request from Satan who says, that's good, but can you add a cancel button? We had some clients that their geolocation isn't great. They'd like to cancel and maybe geolocate via some other means or prove that they're at the store. And then, so you continue the downward spiral, and I didn't actually finish writing this piece of code. It's broken. If you click find nearby stores and click it again, it like weirdly undoes itself, because why would I spend so much time writing shitty code just to make it work? So this doesn't work, but you could imagine doing something where you track a sequence number of how many operations you've done. Maybe you could also keep track of the last promise that you would have stashed from the result of here, and then in every one of these callbacks you check if it's the most recent promise, and if not, that means it was called again, or it was canceled, and then you need to, it's just the worst. It's just the worst. So I'm gonna go on a limb and say that you've probably bargained with a designer or somebody making a feature request that said, or you basically had to water down what they're asking you to do because you didn't know how to cancel an async operation. I know I have. I'm assuming that everyone else is probably guilty of that. That's fine. You don't need to like build out every single harebrained feature that a designer asks for, but it sucks when you have to say no when Ember tells you no, or React or whatever says this is too hard to do, and it really shouldn't be. So this is where Ember Concurrency comes in. And so I've rewritten the previous code to use the so-called Ember Concurrency tasks. And really the active ingredients are just this part here where you're getting coordinates and then also passing it to get the nearby list of stores. But this actually hits all of the use cases, all of the corner cases from the previous code. If I button mash this thing a bunch of times in a row, it's not going to keep on sending me progressive results. And also I can cancel it and it doesn't break. I don't really want to open the console and risk that in a live presentation, but there's no weird errors or set on destroy or anything like that. It's just safe. And I'll kind of go into different things that really go into it, but if you've never seen Ember Concurrency before, if this is new to you, it's probably a lot of information. So, well, I just want to point out maybe a few things that are interesting about this example. One is that there's no is submitting flag. Yeah, the things people get excited about at EmberConf. So there's no is submitting flag. So somehow that is addressed. There's no is destroyed kind of defensive programming checks. There's no checks to see if I'm already running because that means I have to prevent concurrency by returning early. And this might be new to the Ember Concurrency veterans in the crowd, but there's no sets at all in this line of code. There's no setting a sideways result property or anything. So this is actually going to be what I'm sort of focusing more on in this presentation than I have before. Deal with it. So what actually is Ember Concurrency? I showed you an example of using it, but like, is it a bunch of different APIs? Is it just one thing? And it's really just one thing. It's a task primitive, and 99% of Ember Concurrency's API involves using tasks. And really, a task is like, usually it means you took an action, something that was an actions hash, and you moved it to a task, and you use the generator function syntax, and you implement it as a task instead of an action. So what does a task give you? It gives you a better syntax for expressing async operations, similar to async await, but in a manner that gives you cancellation. It supports cancellation, first class. It is also a declarative API for constraining concurrency. So not only can you express these operations in a nicer fashion that's cancelable, but you have an API that prevents these operations from happening at the same time using any number of approaches. And what I'm focusing on more in this presentation is it gives you a bunch of derived state. So as an example of the syntax side of things, I've implemented the same async operation twice, once as an Ember Concurrency task and one as an async function, and they both just count to 3. Here's the task running, here's the task canceling after 2, here's the async function variant, but this button is not actually possible to implement in any easy, simple, Ember-y feeling manner, because async functions, as defined by the JavaScript specification, are not cancelable. They're lovely, but the fact that they can't be canceled is kind of a deal breaker, because it means the only way that you can cancel is to basically any place that there's an await, you'd have to add some logic after the await to see if you've been canceled. That's kind of the exact sort of defensive programming that you want to avoid. And there's no TC39 spec for async function cancellation. There was, but it was withdrawn a few months back, and the latest I've heard is that we should probably get used to just using generator functions for a while, which Ember Concurrency has been using for a year anyway, so we don't have to change anything from our end. And if this is like sad news, if you'd rather use the nice async function syntax, at least you can take some solace in the fact that the way Ember Concurrency treats generator functions is semantically identical to async functions. The only thing you need to know to do is take any instance where you're awaiting a promise and replace it with a yield, which is the generator function keyword that you use, and not await. So back to all the things that tasks do. It's not just syntax, it's also a declarative API for constraining concurrency. And always when I say constraining concurrency, it usually just means make sure only one of these is running at a time. So yeah, that's really often the hardest part. It's not that Ember Concurrency is empowering you to just like spin off 6 billion different asynchronous tasks at the same time. It's really UI driven, and UIs are usually dealing with the problem of how do I make sure that things are properly cleaned up and canceled and only one thing is happening at a time. So this is where the so-called task modifier API comes in. So if you just run an Ember Concurrency task, Ember Concurrency isn't going to prevent these from overlapping in any way. That's the default. There are no concurrency constraints. If you want to constrain concurrency, make sure that one thing is running, you've got a few options. There's a few ways that you can do that. One is to use .drop. Drop is probably the most common one, and it's the one that we used in the example before. It means that if there's already an instance of this task running, then any attempt to perform a new task gets immediately canceled. And any canceled task instance that is canceled before it can even start, we just say it's dropped, and hence that's the word that we use for the task modifier. NQ is a different version that we can use. I never use NQ. I thought I would, but no one really uses it. I mean, a handful of people do, but it's a little bit too much magic in practice. But the other one that is really common and popular, I think the most popular ones are drop and restartable, and there's one or two more that I'm not going to bring up. But restartable is when a task is already running, if you try and perform it again, it's going to cancel any prior instances, and then that makes room for the new one to run, and it runs immediately. Some of you may or may not know that there's a thing called task groups. I don't use these, but I wanted to sort of just highlight that they exist. So all the previous examples show you how to constrain concurrency for a single task, but what if there's different tasks, different operations, and you want to make sure that only one runs at a time? What you can do is you can use a task group. You can say that upload file is a task that is of the mygroup task, and mygroup is defined as a task group that is restartable. And what that means is that if you try to perform any of the tasks in one of these groups, it's going to cancel any prior instances also in that group to make room for the new one to run. So as I go between these cancel buttons, every time I perform it, it's canceling the other ones going. There are use cases for this. I haven't actually personally used it yet, but I definitely got started on it pretty early because people that were early adopters had use cases for this sort of thing. And so this is all stuff that I've presented on before, but I don't really think I've talked too much about the so-called derived state, which I want to focus on a little bit more. And by derived state, I just mean there's always an opportunity, Ember is always going to allow the flexibility to let you track your own state by introducing another property on a component or a controller or a router or whatever. And you can just manually update the state of that over time. So you could have used is my task running, you could have done is submitting from the earlier example, and then put a bunch of this.sets to update that value over time. But instead of doing that, there's actually a lot of properties that are kind of built into tasks and these task instances that you should know about because they can save you a lot of pain and a lot of error-prone code. So it's a very basic example of some stuff that's given to you for free. Is running, I didn't actually show you any of the template code before. I will soon for that example with a geolocation. But if you have a task that's called ship widgets, I'm probably gonna screw up that one if I say it a few times. Ship widgets, and you perform it, then is running is gonna go to true. Perform count is gonna increment, it's one of the newer ones. Concurrency is always gonna reflect the number or the current number of running tasks. So this one doesn't have any concurrency constraints, so if I just button mash this thing, concurrency is gonna go up and then it's gonna go down. And if anybody ends up, playing around with these slides later, it's kind of a fun game to see how high you can get concurrency before it goes back down. Somebody actually cheated and made like a little jQuery plugin to tap the button a million times. It's, again, the things that people get excited about. So there's way more derived state than just what I showed on the previous slide, but I wanted to sort of highlight a quick thing because I don't think that very many people appreciate this aspect of Ember concurrency so much. And I keep tabs of how people are actually using this stuff. There's like public GitHub repos that use it. Sometimes people will send me code snippets if it's something that came out, even they're using idiomatic Ember concurrency, but it still came out a little weird. So one that I've seen a handful of times, it's almost as if people don't even know the API sort of exists, or they just haven't sort of practiced this style of thinking. But if ship widgets has a is shipping widget Boolean property that it's managing the state of, then it's tempting to say, okay, I'll just set it to true at the beginning of the task and set it to false at the end. But there's obviously some problems with it. It's completely redundant. Why would you ever introduce more state that you need to track yourself and probably get wrong when you can use just something that's built in? It's a point of failure. Your chances are you're probably going to reorganize when these things get set to true and false, and it's gonna break in very subtle ways because when you write code this way, there's all these timing dependencies for when you set properties and when you decide to mutate some property on a component. And it's actually broken. It's not just error prone, this is actually wrong, because if you were to cancel this task while it's paused on this line of code, then this line is never gonna get run and you're gonna have is shipping widget be set to true even though nothing's actually shipping. There's another instance that I didn't write down here, but it kind of just struck me. This can run concurrently because there's no constraints. And if you run this 8 times in a row, the first task to get to this line of code is gonna say is shipping widget false, even though there might be 7 more instances that are still running. So use derived state when you can because you're probably gonna get it wrong otherwise. Because we're dealing with concurrency, concurrent programming is really hard. So use what's given to you. And there's sort of a minor problem I wanted to point out. It's not as big as the other issues, but every property that you introduce, every piece of state also needs to have a name. And developers like to bicker over how to name things. Would you call this flag is shipping widgets or is ship widgets running? Maybe another developer would have a problem with that because that meant you'd need to capitalize the S and then it's harder to grep. And so there's all these little death by 1,000 paper cuts problems that you can avoid when you just use the state that is kind of built into a task. And then you can just very easily just grep your program and see what are all the components that updates when ship widgets state changes. So it's a minor problem, but it kind of comes up a lot. And it's one of these cases where it's just a little bit of convention that prevents a lot of like drift between apps, between developers. So if this task returns 1, 2, 3, you would think that there's some way that we could actually access that. And you already saw an example where you did with the geolocating example. We didn't use .set, so obviously somehow we were taking the return value of that task and bringing it to the screen. So would it be shipwidgets.value? Would it be something else? And so I want to talk about how Ember concurrency is put a lot of effort, a lot of the API design that went into it is there to respect the fourth dimension being time. Because there's I've seen a lot of attempts to build nice conventions over promises, promise proxies, but the conventions cut a little too deep, I guess is one way of putting it. They kind of choose a happy path that plays favorites and doesn't actually make it easy to design a variety of async use cases. So we want to honor convention over configuration, but we don't want to take it so far that it actually hurts our own creativity. So convention over configuration is great when these shared battle-tested conventions don't limit your potential, don't limit your creativity. But when they do, and when they play favorites, when the APIs make certain use cases and data flows really easy to do, but others really hard and sort of make you feel bad for even trying them, that's obviously not good. So I'm trying to avoid that with Ember Concurrency. And I think an example of this, and it's kind of a API that I worked on a few years back, but the fact that you're very much encouraged to load models in the route model hook, and there's this sort of a subtle shame that if you ever try to do data loading in components, the framework just slightly punishes you for wanting to do that. But if you don't, and you load all of your data in the model hook, then you're sort of in a class of Ember apps that sort of feel very similar to all the other ones. You know that when you click a link, you might use a loading route and it's cause some overlay to go over there, and it just doesn't go there immediately. It's just, you can tell you're dealing with like a 2013, 2014 Ember app. In the same way that if you started off using Twitter Bootstrap, the CSS framework, and you never really fully separated and built your own thing, then it's just another app that looks like a Twitter Bootstrap app. So this is sort of that effect applied to when convention over configuration picks sort of favorites with certain use cases. So Ember Concurrency doesn't always provide a particular convention, but it gives you conventional language to express. It doesn't choose for you what kind of data you want to display, what is the most recent successful value from a task that completed. This will all make sense in just a moment, I promise. I know I'm mixing the words up. But this is a long way of saying that it isn't just shipWidgets.value, it's shipWidgets.lastSuccessfulValue, and last successful could actually be any number of things. So let's actually dive into what that means. So it's not .value, this is always going to be undefined. But you could use shipWidgets.last.value, or you could use lastSuccessful.value. So what are these what are these properties I'm talking about? What is last successful? So when you perform a task, it creates a task instance, which represents a single execution of that task, which may run to completion. It might fail with an exception, it might be canceled, it might possibly be canceled before it even has a chance to run if you're using the drop modifier. And it's these things that actually expose the .value, the .error, rather than it being some sort of upper level global property on the task object. So if you recall this example, if you perform this a bunch of times, you're going to be creating a bunch of task instances that belong to my task. And .value and .error exist on here. And when you want to actually have access to those values, because they're very useful for driving data in the template, you basically have to say which one you actually want, because there's multiple task instances that'll be created under a given task. So in other words, with concurrency, there isn't just one .value, there isn't just one attempt to load the data on the screen, there isn't one attempt to hit the server. You have to sort of tell Ember Concurrency which is the one that you actually want. And when you do, you have the freedom to basically define how stale or how eager your UIs are when you start reloading, you get into like reloading data. So the top level task, in this case, shipWidgets, exposes properties to recently performed task instances. One of them is last, which is the one that you just performed, which might still be running. It might eventually run to completion or have an error. Last successful is the last one that ran to completion and returned a value. Last errored is the one that threw an error, which can be useful sometimes for displaying like error loading banners and some other things. I don't expect you to really take very much away from this slide, but just to make it clear, these are sort of there's last and last successful and last error. These are task instances that shipWidgets, the task, will maintain a reference to, and every task instance has a value, and error is successful error. So is this Clown Town? Is this, have you flipped the bozo bit on what I'm saying? Am I really expecting you to learn all this stuff? Well, really, I'm actually expecting you to maybe, if you're interested, learn 2 properties on a task and a few properties on a task instance, and mentally construct that matrix in your head of which piece of data you actually want. But right, I mean, at its worst, you end up with code that sort of looks like this. So why would you ever do that? So to come back to this old example, I didn't really show you the template code for this, but just so you know, have a sense of what this looks like in practice, here's the piece of code that actually exposes data to the template. We say with submit form.last successful value as result, and then we just loop over it and display all the stores. And that's how this works. And we use last successful here, but with just a slight tweak of the property that you use to drill down to the specific task instance whose values, whose data you care about, with just a slight tweak, you can sort of change this UI from something that is always displaying data, even if it might be stale, even if the user has already expressed interest in getting a more up-to-date version of that data. You could just make one change. You could replace last successful with last, which this is the only thing that changed down here. And then when you've already got results, then when you press the button again, the results clear, and you've basically chosen an API that is as fresh as possible, that never wants to display stale data. And this might seem like a minor thing, but it's one of these cases where usually the APIs play favorites. They promise proxies. You have to swap out the property, which meant you lost access to the old attempt to fetch data. And it's just one of these like slight missteps that makes it really hard for you to move between different styles of async data loading with any sort of like alacrity. So it's really nice that all that you have to do is just change one property. Which value do you want? Do you want the one that last completed? Or do you eagerly want the newest value, even if it doesn't exist yet? It makes it really, really easy. And so really this just boils down to the fact that Ember Concurrency pays a lot of respect to the concept of essential state versus accidental state. And these are terms that are sort of originated from a white paper from I think 2006 called Out of the Tar Pit. And basically is a paper that talks about the common cases of complexity that come out of software. And they sort of say that the root of all evil and the cause of a lot of complexity is the so-called accidental state. It's a state that you don't actually need to reconstruct, the page that you're viewing or the operations that you're doing. It's just a state that sort of got duplicated, even though you've sort of expressed it elsewhere and could just rederive it. And just a very simple example is if for some reason you had an object in your code that was a user's array that had 2 elements in it, but you also had a user count saying 2, you should wonder why this is there. Why did I need to actually make this a piece of data that I may or may not have to update over time when it's just, I can always just say users.length. Why would you ever do that? So that's a very simple example of accidental state. And the antidote of accidental state is to use derived state, which is a way of just recomputing the values that you need based on this bare minimum essential state. And in Ember, you probably have some experience with using derived state if you use computed properties. So these should be familiar concepts. The only thing that's new about Ember Concurrency is that it pays due respect to derived state over time. It keeps just enough amount of information to make it really easy to do sort of comparisons. Has the data changed? Is the data stale? All these different things that are usually pretty hard, and without something like Ember Concurrency usually requires a lot of manual state tracking, which is really easy to get wrong in an async concurrent environment. So in general, this is just the idea that you should prefer declarative APIs over imperative APIs. Because property mutations, particularly when interleaved with a bunch of async operations happening at the same time, quickly leads to just a combinatoric, unreasonable mess of code that is just going to be error prone and is really hard to change and evolve over time. So as much as there's never going to be a silver bullet, and Ember Concurrency definitely has its warts and its problems, it's definitely worth taking some time to sort of think about these async problems using derived state. And I'm hoping I can get more people interested in it because I want Ember Concurrency to give you even more than there already is. So it takes practice to think in this way, but I think it's worth the effort. And I think it's also kind of exciting because Ember's concurrency is kind of the only thing like it. I haven't seen anything like it. There's actually a few copycats coming out. There's a React concurrency. I don't think I saw an actual Angular concurrency, but I saw an article that is re-implementing that task function for supplying a generator function that runs async logic. And so I think people recognize that this is missing from other worlds and that we're kind of privileged in Ember to have this. So hopefully you might get excited about this and talk through some of this stuff with me. But so in conclusion, Ember is really just three things. It's a powerful syntax for expressing async in a way that's cancelable. It's a powerful declarative API for constraining concurrency. And it's a ton of derived state that you can build really expressive UIs with without going down the path of mutating a bunch of properties and managing state over time. So that's it. Thank you.